On the waveform monitor, we'd be looking at the horizontal blanking interval. On the Vectorscope, we'd watch the color burst. Timing the video system prevents horizontal jumps or color shifts in the picture when switching between video sources. Now let's perform a system timing. With the waveform monitor and Vectorscope connected to the program output of the switcher, select a signal source reference on the switcher, usually the black signal. Make sure both the waveform monitor and Vectorscope are set to external reference. This makes these units reference to the same signal the whole studio is using as a reference. Using the waveform monitor's vertical position control, move the sync pulse leading edge so the halfway point falls on a graticule marking on the horizontal axis. Use the horizontal position control to place the leading edge of sync on a major timing mark. It should look like this. This position will serve as a reference point for all other inputs. Now, use the Vectorscope's phase control to position the color burst at 9 o'clock. Remember, don't adjust the waveform monitor or Vectorscope controls. Use the switcher to select one piece of equipment to be timed. In this instance, we'll use video camera number 1. Adjust the horizontal phase control on the input source, camera 1, so the sync pulse leading edge is at the reference position previously established, like this. Now, viewing the Vectorscope, adjust the SC phase of video source 1 to set the color burst at the 9 o'clock position. Sometimes there are 2 phase adjustments. If so, adjust the coarse first, then the fine, to the precise burst alignment. When they are aligned, you've completed timing on video source 1. To time the whole studio, you would repeat this procedure with each piece of equipment. Having the equipment properly timed will ensure your input transitions are clean. Now let's talk about TBCs. Time-based correctors are an important part of the timing and genlock process since they stabilize the output of VTRs. For example, TBCs remove signal timing errors caused by mechanical jitter. It's the TBC itself, not the VTR, that is timed to the system, thus system timing. Many VTRs have TBCs built into them, and they're treated identically as separate units. TBC adjustments need to be checked, if not readjusted, every time a different tape is played back. That's because video levels and hues recorded on tape sometimes differ from facility to facility and VTR to VTR. These differences can be adjusted for by playing back color bars. In fact, that's why we always record about 1 minute of color bars at the beginning of each tape. Here's how to make the TBC adjustments. First, on the waveform monitor, check Setup or Black Level. It should be at 7.5 IRE. Next, adjust Video Gain, which is the brightness and chroma or color of a signal. Make sure the 100% white level coincides with the 100 IRE. Now, on the Vectorscope, make sure the color burst vector is correctly positioned on the graticule. Then adjust the hue controls on the equipment under test to rotate the dots into or near their graticule boxes. Finally, check chrominance levels. If the dots are beyond the boxes, the chroma amplitude is too high. If they fall short, it is too low. In either case, adjust the chrominance gain control on the VTR to place the dots in their boxes. That's how simple it is to make TBC adjustments. Just remember, TBC adjustments must be made while playing back a recorded color bar signal. Have you ever completed a shoot and realized you used the wrong filter? Like shooting outside with an indoor filter? It happens. This is what it looks like. And here's how it appears on a Vectorscope. It actually seems like a white balance problem with too much blue. Here's how it would look with the proper filter. White balance is the process of balancing the camera's red, green, and blue channels. By now, you've probably figured out there is a difference between electronic visual reproduction and other visual reproductions. Painting, for example, is a subtractive system. When you mix the primary colors, you get a dark brown or black. Video is just the opposite. It's an additive system. Mix the primary colors in the approximate amounts of 30% red, 60% green, and 10% blue, and you get white. Now let's check the white balance. First, be sure to connect the video camera signal to the Vectorscope input. Next, point the camera at a white reference. Use the variable gain knob to expand the trace. Remember, the center of the display is black and white, so we not only get color information, but can also see if there's no color information, which is useful during white balancing. Then press the camera's auto white balance. Here's how the signal will appear if the camera is working properly and the white balance is correct. After checking for white balance, you must check for black balance. When you press auto black balance, the camera will cap its lens. On some older cameras, you might have to manually cap the lens. If the black balance is correct, you'll see a fuzzy spot in the center of the Vectorscope display, again indicating no color information. Many times in a studio, you'll want to color match two cameras. This is accomplished by performing a manual white balance. Start by pointing two cameras at the same white reference. Adjust the iris on each camera to match luminance levels on the waveform monitor. If a color channel in a camera is out of balance, the fuzzy spot on the Vectorscope will be over toward the corresponding color's graticule box. To fix this problem, you must go back to the original source and adjust the blue, or in this case, the red gain on the camera control unit. It's a good idea to never touch the green control. This can create major color balance problems. Adjust these controls until the fuzzy spot is at the graticule's center. Once you've used the Vectorscope to match both cameras, you can pull the cards and fine-tune colors of the scene. The Vectorscope also comes in handy when you're trying to identify colors. This works particularly well when you need to generate a background for a scene you shot, say, a week ago. And now you need to match the color. With the Vectorscope and the waveform monitor, it's easy. Adjust the background luminance, chrominance, and hue controls. As you can see, a perfect match is assured. Proper use of the Vectorscope, along with the waveform monitor, allows you to accomplish many important production procedures. Having a system that is timed, with properly adjusted TBCs, and cameras that are white balanced and matched, lets your audience enjoy the beautiful and colorful images you've worked so hard to create.